Hi, today we'll discuss the LeetCode problem number 8, string to integer, as known as atoi. Implement the myatoi function, which converts a string to a 32-bit signed integer, similar to the atoi function in C or C++. In C programming language, atoi means ASCII to integer. The atoi function in C takes a character string as input and convert this character string to an integer and return as a result. For example, if we have a string 1, 2, 3, our function will convert this string into an integer 123. Here's int, and the input is a string. Here are the list of things we need to take care of in the algorithm. First, read in and ignore any leading white space. For example, if we have a string starts with white spaces and 1, 2, 3, our function will return the integer 123. So the white spaces are illimited. For the requirement number 1, we can simply use the trim function in the Java library. Our input is s. Here we have s equal to s.trim. Items number 2. Check if the next character is a negative sign or a positive sign. This will determine if the final result is negative or positive. For example, our input is negative 1, 2, 3. It will return negative 123. And if it has a positive sign, then it will return positive 123. For the requirement number 2, we can compare the char at the current position. So here it says the char at the current position indicated by the index in the input string equals to the positive sign. We also need to compare if the char at the current position equals to negative sign. The requirement number 3. Read in next the characters until the next non-digit character or the end of the input is reached. This requirement means after you trim the spaces and after you read in the sign, you start to read in the digits. And the process will end if it reaches the end of the string, or until you read in a non-digit character. For example, you have A, B following the last digit 3. So in this scenario, our function will return the integer 1, 2, 3. So first, it will eliminate the spaces and read in the sign, then continue to read the digits 1, 2, 3 until it reaches the non-digit character, then our process stops here and return the answer as 123. So for the requirement number 3, we need a while loop to read in the digits from the input. Here, we will stop our while loop while the end of the string is reached. And in our while loop, we will check if the current character is a digit. And if it's true, we need to append this digit to our answer. So before all these steps, we have an integer answer. And if it's true, the answer will be updated as such. And here, we need to convert the character into an integer. So here is a digit. And the way to convert the character to an integer is to use the digit minus 0. For example, if the character is 1 and the 1 minus the character 0 will give you the integer 1. And else, if the character at the current position is a non-digit, we'll stop this process. After reading in the current character, we'll increase the index. Then we repeat the loop for the next character. The requirement number 4. Convert these digits into an integer. For the requirement number 4, once we have our answer, we'll return the answer as an integer. And before we can return our answer, we have to take care of the sign. So we will declare another integer sign equals to 1. If the sign we read in is a positive, we don't change this value. When the sign we read in is negative, we will assign the sign equals to -1. So when we return our answer, we have to use our answer times the sign. So if our answer is 1, 2, 3, the sign read in is negative, then the answer will be -1, 2, 3. Actually, this step is the requirement number 4. And this step is the requirement number 6. Return the integer as a final result. Now let's come back to the requirement number 5. If the integer is out of the range is from -2 to the 31st power to the 2 to the 31st power minus 1. If it's out of the range, then claim the integer. It will remain in the range. If the integer is less than the minimum, then our function will return the minimum as the answer. If the integer is greater than the maximum, then our function will return the maximum number as the answer. So for the steps number 5 will happen in the while loop. Inside of the while loop, every time we update the answer at step number 4, we need to check if the current value of answer is out of the range by comparing answer with the max number and compare the answer with the minimum number. The integer value of the max number in our problem is and the minimum value is and in our process, when we update our answer digit by digit, all the digits are positive. Our current value of the answer is always positive. So first, we will compare the answer with the maximum value. So here, if answer is greater than max. Inside of this if statement, we need another statement to check the sign. If sign is equal to 1, which means our input string will be converted to a positive integer. Then we'll return max. Else, the sign will equal to -1, we will return mean. For example, our answer is greater than max. One possible value is our answer is this number. If you compare this number with the max, it's 1 larger than the max number. So if the sign is equal to 1, then we will return the max. If the sign is -1, then you can see our answer is the same as the minimum plus the negative sign. So in that case, in the else case, we will return the minimum. Okay, this is a pseudocode for our solution. It covers all the requirements in this problem. Next, we will go to the LeetCode website to implement our solution. Here is the pseudocode I prepared in the LeetCode website. And these are the values for the maximum number and the minimum number. And the first step in our pseudocode is to ignore the leading white space. This is requirement number 1. We'll implement the step number 1 by using the Java string function trim. The step number 2 will check for the sign. See if the character is a negative sign or positive sign. This is requirement number 2. We'll declare an integer variable index. We compare the character at the current position with the negative sign. Of course, we have to make sure our index is within the range. Before we can do this comparison, we'll need to declare 2 variables. the length of the string, and the index of the current position. And also, we need an integer variable, sign. And we default the value to 1. And the possible values for the sign are 1 or -1. So inside of this if statement, if it is true, then we will assign the sign to -1. And then we move the index to the next position. Else if we'll check for the positive sign. If the character is read in is a positive sign, then we just move the index to the next position because the value of the sign is already 1. So here's the if statements for the requirement number 2. After we read in the sign, then we start to read in the digits. We'll need a while loop. Inside of the while loop, we have requirement number 3 and 4 and 5. Number 3, we will read in the characters digit by digit until non-digit character or the end is reached. The condition for the while loop will make sure it will continue the process until the end of the string. And here we'll have if statement to check if the current character is a digit. If it's true, then we will convert the current character into an integer. This step, we convert the digit to the integer by doing the math operation on the characters. Then we will append the digit to the answer. We will declare the variable answer outside of the while loop. For our answer, we will use a long type because it is possible that the value of the answer is larger than the maximum integer or smaller than the minimum integer. At step number 5, we will check for the overflow and the underflow. If it's greater than the max, then we'll check for the sign. If it's smaller than 0, we will return the minimum. Otherwise, we'll return the maximum. So here are the steps for the requirement number 3, 4, and 5. And if the character read in is a non-digit character, then we will break the process. Once we finish processing the current character, we'll move the index to the next position. And here is the last step, number 6. Return the integer as a final result. First, we will convert our answer to the integer because we declare the answer as a long type. And then, we will multiply the answer with the sign. Okay, here is the implementation of the solution. Now let's test our code. Our implementation works. The first test case is the string 42. Let's add some white space before the digits for the requirement number 1. we have an index out of bound exception. The reason for that is because we need to move this statement after the trim. Now it works. Let's modify our test case by introducing a negative sign. Let's test with positive sign. Let's append some non-digit characters at the end of the string. Alright, it works for all the requirements. Let's submit the solution. The submission failed. The failed test case is an empty string. And the reason for this failure, as indicated by the LeetCode, is because the index is out of the bound. To fix this issue, we just need to move this condition before we check for the negative sign. And we will make the same change at else if condition. Okay, let's submit the solution again. Our submission was successful. The runtime is 4 milliseconds and is faster than 33% of all the online submissions. The solution we have implemented is straightforward and there's not much we can do to improve the performance. Sometime if we submit the solution again, it will use less runtime. As you can see, after we submit the solution again, now the runtime is only 1 millisecond and is faster than 100% of all the online submissions. The runtime of our solution was 1 millisecond. And it was faster than 100% of all the online submissions. And we got this performance in our second submission. And the first submission, we had a runtime 4 milliseconds. So there's not much we can do with our solution. The solution is very straightforward. In this problem, all the implementation we did is to take care of the requirements from number 1 to number 6. Okay, we end our discussion now. Thank you for watching.